internet has made a lasting impression across the globe, and its reach shows no signs of slowing down. Year after year, millions of new users are added to the digital ecosystem. And when you start to consider the sheer magnitude of those figures, it's not hard to believe that this type of volume could put a strain on the back-end services of popular websites. To accommodate the scale of these requests, multiple servers are needed to facilitate the exchange of data. However, the act of adding multiple servers doesn't quite fix the problem because performance hasn't been factored in yet. Even with the additional support, user requests can surge and overwhelm server resources. In order to manage network traffic and limit any degradation to the server, load balancers are installed to ensure only the optimal volume of incoming requests is distributed to a single server. If the load exceeds the capacity of a single server, a load balancer responds by distributing the incoming network traffic across multiple servers. In a nutshell, a load balancer functions like a network traffic cop. It routes client requests to the servers that are best able to fulfill those requests. If a server starts overheating and cannot respond quickly enough, the load balancer will divert the traffic load to another server. This is also true if a server goes down, but load balancing technology isn't exclusive to backend servers. Load balancers can also perform the same process for web applications, APIs, and SaaS applications. Load balancing is necessary for a variety of reasons that fall into two broad categories: technical and business. Technically, load balancing is needed to protect web-based systems from outages caused by a single point of failure. For businesses, this is vital to delivering a consistent, positive user experience. As far as types of load balancers, there are essentially two types of load balancers: hardware load balancers or software load balancers. Hardware load balancers are best for rapidly handling large volumes of traffic from diverse sources. This is because they are usually built on high-performance appliances. Software load balancers are more flexible, offering the same functionality as their hardware peers while running on standard hypervisors and saving rack space in data centers. Well, I hope that gave you a quick rundown on load balancers. Ultimately, where there is a load, there will be load balancers. The technology is varied and flexible. Hardware-based and software-based load balancers each have their best use cases. Static load balancing algorithms may not be optimal in all cases, but they are easier to set up than dynamic load balancing algorithms. Choosing the right placement of the load balancing function will provide further flexibility in addressing load management workloads.